We're going to have a look at how to solve simultaneous equations, but notice that in this case we actually have a quadratic term here, x squared. This means that we can't just multiply this one by 2 and subtract it, as the x squared and the x term will not cancel out. We need to adopt a different method in this case. What we're going to do is something called substitution. We're going to make either x or y the subject of one of these, and then once we know what x or y is equal to in terms of the other, substitute it into that second equation. Usually we want to try and avoid fractions if at all possible. I'm going to choose this expression here, and I'm going to rearrange this to be y equals 6 minus 2x. I could have made x the subject, but then I would have had to divide through by 2 and I would have had a half y, and fractions tend to lead to errors. Okay, now that we know that y is 6 minus 2x, we can replace this y here with 6 minus 2x, as that's what y is. So we've just taken that y there and substituted it in for what we had y equal to. Now all we need to do is solve this quadratic. So we'll keep the x squared positive and just bring this term over here. Always have a quick check to see if your quadratic factorizes. If it does, we can factorize it and solve it nice and quickly. If it doesn't, then we can just put it into the calculator and it will tell us the solutions. So we've got our two values of x which will work. These two equations are both satisfied when x is either equal to 3 or minus 1. All that we now need to do is find the y value for which that will be true. So, bearing in mind we've already made y the subject of this equation up here, we can substitute both of our x values in here to find the y. If we do that, we'll get 6 minus 2 times 3, using our first root. That gives us 0. So we know one coordinate of where these two graphs would intersect. If we imagine that we were to plot both of these on a set of axes, we know that they would intersect when x is 3 and y is 0. Okay, that means that both the equations are satisfied when that is true. Remember, simultaneous equations is just finding where graphs intersect. And then secondly, we would have y equals 6 minus 2 times minus 1. So we're going to get 6 plus 2 is 8. The second point of intersection between this line and that quadratic.